Hi everyone. Today we're going to study horizontal and vertical asymptotes. Let us define asymptote. Asymptote is a line that a graph gets closer and closer to, but never touches or crosses it. Here we have a figure and we have this graph. This red dotted line is what we call the vertical asymptote, while the green dotted line is the horizontal asymptote. For example, we have this function y equals the fraction 1 over x minus 2 plus 4, and this is the graph. Now the vertical asymptote is the equation x equals 2, while the horizontal asymptote is y equals 4. Let us define vertical asymptote. A line x equals a is a vertical asymptote of the graph of a function y equals f of x if either the limit of f of x as x approaches a from the right is equal to positive infinity or negative infinity, or the limit of f of x as x approaches a from the left equals positive infinity or negative infinity. Now let us define horizontal asymptote. A line y equals b is a horizontal asymptote of the graph of a function y equals f of x if either the limit of f of x as x approaches positive infinity equals b, or the limit of f of x as x approaches negative infinity equals b. Now, given the function y equals f of x, and this f of x is a rational function, and this is equal to g of x over h of x. In this video, we will confine our example for the g of x and h of x are both polynomial functions. Now let us show how to find horizontal asymptote. And our equation is y equals b. For our first step, we will evaluate the limit of the function as x approaches infinity. And this must be equal to a value that is b. And then we're going to write the variable y equals this value b. And this is now the horizontal asymptote. Take note, there is no horizontal asymptote when the degree of numerator is greater than the degree of the denominator. Now let us show how to find vertical asymptote. And the equation is x equals a. First, let us equate h of x equals 0. This h of x is the denominator of the function. And then we will solve for x. The resulting equation for x is the vertical asymptote. Take note, the vertical asymptote occurs when x equals a, produces zeros in the denominator but not in the numerator. When this case occurs, that is y equals 0 over 0 at x equals a, then we say there is no vertical asymptote. Let us see this example. Find the horizontal and vertical asymptotes for the function f of x equals negative 5x squared plus 7x all over 3x squared minus 1. Let us begin finding the horizontal asymptote. The step 1 is we will evaluate the limit of this function as x approaches infinity. We note here that the degree of numerator is equal to the degree of the denominator. So as the theorem says, the answer here is negative 5. That is the coefficient of x squared in the numerator. We write it here over the coefficient of x squared in the denominator. So this is negative 5 over 3. And for step 2, we will write y equals, we will take this value and we put it here. So the horizontal asymptote for this function is y equals negative 5 over 3. Now let us solve for vertical asymptote. Let us equate this h of x or the denominator equals 0. So we have 3x squared minus 1 equals 0. And let us solve for x. This negative 1, we're going to transpose to the right, so it becomes positive 1. And let us divide this equation by 3. So we will have now x squared equals 1 over 3. Looking for the x, let us take the square root of both sides. So we have the square root of x squared is equal to plus or minus the square root of 1 over 3. On the left side, we can cancel the radical and the power 2. So we have two values of x here, and when we split it, we will have x equals positive square root of the fraction 1 over 3 and x equals negative square root of the fraction 1 over 3. Take note that the two values of x here, when substituted, do not make the numerator of the function f of x equal to 0. So we have here two vertical asymptotes. So here are the horizontal and vertical asymptotes of the given function. Remember, the horizontal and the vertical asymptotes might happen when the function is rational or quotient, exponential, logarithmic, etc. There are definitely no asymptotes for polynomial functions. I hope you learned something from this video. See you again next time.